Hello everyone. Today I'm going to cover a little bit with the broad scopes of mobile technology and mobile application developments. The mobile technology ecosystems may consist of these many things. I would say this is not the complete, but it contains most essence, and it would include more in the future as technologies evolve and advanced much. So let's take a look each of those. Mobile devices. Mobile technologies applications should be developed on a hardware, and it should be operated on a hardware. So one of the typical the hardware is smartphones, tablets, and in this case we are looking at smartphones. Although we can develop also smartwatch app and smart TV apps, with the foundations that you learn from this class, you may extend further to wider areas. Okay, that is something that you can do in the future. Tablets, wearables like smartwatches, fitness trackers, IoT device. This is very, very popular, and also many the robots and then CE I would say that is a remember the CES show held in Las Vegas weeks ago. That type of equipment, for example, home appliance. Now, if it is called smart, then IoT device is embedded. So IoT could do something about processing, something about communication, something about the intelligence. Okay. So AR, VR, mobile devices, automotive integrations. So you name it. It's a lot more than this, right? It's starting from Tesla, but now most of the many other manufacturer companies also developed the auto pilot capabilities in it. So it contains IoT devices and to utilize it. Key components inside the device. It has a CPU and GPU and neural engines. So Tensor chips, A series, Snapdragons, RAM and storage, of course, there, right? For example, if you have some experience on Raspberry Pi, which is IoT, then it has a RAM, which is the process memory, and also it could have some storage. Although Raspberry Pi has an external storage, particularly on SD card, right? And radios for the communications. This type of radios are possible. for example, smartphones, then the communication is in 5G and Wi-Fi is possible, Bluetooth, NFC, and also more and more, right? Raspberry Pi also can support 5G, Wi-Fi, Bluetooth. I am not sure. NFC, probably not. More with the GPS, accelerator. Those are the sensors built in, for example, iPhone devices. Accelerometer, gyroscope, barometer, magnetometer, camera sensors, and biometrics, for example, Face ID and Touch IDs. I like MacBook because it has a Touch ID of my finger, so it is much easier. I like iPhone smartphone because it allows us to log in by Face ID. And also battery, of course, the computer devices needs batteries, right? But this is a mobile. The life of a battery determines the life of the capabilities of that mobile devices, right? If there is no power, then no nothing. Fancy and high-end mobile devices will be nothing but the metal, right? So power management is one of the key issues. Like this, there's a slide that shows a lot of those the ecosystems of components. If we look deeper inside each item here, bullet points, it takes somebody works on there for their lifetime, so we cannot cover everything in great details, right? So I'm going to introduce to you so that you can see, oh, there's that type of components needed, and it can play certain role. And if you are interested in further and deeper, then you can find out on your own, right? And so for the hardware, now we need to consider the operating systems. So we call the OS layer. So we have iOS, Android OS, and many other OSs. Core responsibility, then security sandboxing on that iOS, app lifecycle management, some of the security issues, permissions and privacy, and notifications, pull and push notifications available, background task, and energy management. And also to support the users, customers, then they set up app stores for Apple products, and the Play Store, I think that is for Android products. And app development, software layer, then if we are thinking of iOS, then we need to work on Swift. Swift is much easier to code and easier to understand, although it comes from Objective-C, further down C languages. You may be able to see some of specific example later today, then you may see, oh, in this way, SwiftUI, Swift codings becomes much easier than working on Objective-Cs. And then there is a the IDE integrated development environment, which is Xcode. So we're going to work on this, and we import SwiftUI or UIKit. So this is for the user interface. As I said, the UIKit is something that you can learn easily, but when you develop, it has some limits, restrictions, because everything that you have to drag and drops, which means that it's easier, but it's not definitely easier. If you handle everything in codings, that would be much nicer and easier. You will be able to appreciate it. So we are going to focus this SwiftUI. Okay, so Swift and SwiftUI. UIKit, we may or may not. If we have time, then we can see how it works a little bit, but not much, because of these different approaches. So this is something that you need to do as a professionals. And then for Android, the language starts from Java, but now a little bit advanced language called the Kotlin. So Kotlin is popular and widely used. And then IDE is Android Studio. And earlier, I've taught this maybe 15 years ago for Android apps development. Then we have different IDEs. Cross-platform frameworks, there are many others. APIs and SDKs. APIs that or SDKs that we use, depending upon the app. If we are talking about maps, then maps and location services. If you want to use some of the internal embed sensors, like cameras or image processing, then SDK for cameras, that is needed. Some of the sensors, motions and environmental biometrics, then we need to use corresponding the libraries, SDKs. Payment APIs, this is very important, right, in most cases, because we need to increase the revenues. So this is it. Cloud authentications and machine learning frameworks. So core ML or TensorFlow Lite, those are available for iPhone apps developments. Network, this is very, very, very important, right? Your smartphone needs to talk to others. Other means it should talk to peripheral devices like printers and also router. Through the router, it goes out the big world, internet world, right? So network technologies, all kinds of network technologies is needed for iPhone apps developments. And then back-end connectivities, then we're going to use this much, REST APIs. I set up a RESTful server on the Google cloud so that we can use that. And also mosquitoes, if your cell phone wants to talk to Raspberry Pi, then this is another thing that you could do, right? This is a simple protocol that you can use. Or you can set up TCP/IP server and clients on your Raspberry Pi. Then that TCP/IP can be communicating with your iPhones. So that is another way that you can enable some communications. Cloud and back-end services. Cloud, we're going to use GCP or others. Any one of these may be possible. Key capabilities of using or relying on the cloud or back-end services is the authentications, right? We will practice this also. And your ID, your authentication, the login, for example, needs to be, for example, login ID and password. The password can be stored locally on your device, or it could be downloaded from the server. So every time, if you want to log in and you enter login and password, then your cell phone go out to the server, to the cloud, and then let you know whether it is authenticated. Push notifications, your cloud may send some signals to your smartphones or vice versa. So it could be push or pull, right? Your cell phone needs to pull sometimes, or some other times your cloud server push the data into your smartphones. We'll work on this pull services. And real-time database, object storage, analytics, and crash reporting and devices synchronizations. Some additional things can be extended. And then AI and intelligent features can be added. So neural engines, if you are using a core ML or Google Tensor chips, if it is available, then you can do TensorFlow Lite. Yeah, this is something that you can challenge. AI-driven features, voice assistance, predictive keyboard and suggestions, face recognitions, fingerprint recognitions, real-time translation, image and scene recognition, and more. Mobile app distribution and monetizations. App Store has several different app stores possible, and some of the monetary issues needs to be handled that way. Security and privacies. So there is a permission models. iPhone apps like Android, by default, everything is disabled. For example, if you want to access the internet from your iPhone, then in your development, in the coding, somewhere, the property of that, the application, you have to enable it. You have to set up permissions. Sometimes when your app is running and when it comes to for example, access your camera sensor, then rather than simply turn on the camera, but may ask pop-up messages to provide you to interact, saying permit, or once permitted, or always permitted, or while cell phone is or app is using, then that is permitted. So all different kinds of permission models are already available, so you simply use it. Okay. So we'll look at some of these, and then threats. For security reasons, your cell phone needs to protect while app is developed. Okay, so at the development phase, you have to consider to protect or prevent from any unauthorized access or intrusions into your device. So that type of that type of capabilities needs to be included in your app developments. Analytics and quality assurance. This is a little more advanced ones. You may or may not. We're not going to do much about this. Performance monitoring. Everything of this we have to provide, for example. Okay, this is a good challenge that you can practice. Yeah. Stakeholders, of course, the device manufacturers, OS vendors, app developer. We are focusing this, right? We're not any of these. Third party of that. Yeah, we are using their capabilities. Okay, so lab 1 today. We're going to work on Playground. What is the Xcode Playground? That is a coding playground that allows developers to write and test Swift code in on interactive development. This is handy, right? So today we're going to work on this. Today is the first time that we open up Xcode and understand a little bit of Xcode. So this playground, the app playground, enables quick prototyping and experimentations without the need to build a real app. Okay, this is a playground. Particularly the language that we are using, Swift, is not exactly same as, for example, Python, right? You need to practice a little bit so that yeah, language-wise, it is a little different, so that we need to practice the way that you can practice initially on Playground. We don't need to practice everything on Playground. And then as we develop applications, smartphone applications, we may learn. As we learn, we develop. As we develop, we learn more. Okay? It's not separate activities. Okay, how can you activate the playground? When you open up your Xcode, don't forget it should be iOS, and then you click this, and then next button. Then there is a signing and capabilities. If you click this on top of this folder, so that you need to sign up or sign in. If you are already signed up, then you need to sign in every application, so that you need to have that. And then by default, it gives you two files, two Swift files. myapp.swift. This is by default. It shows like that. Content view Swift. So this, the name here, although it is given to you all the time, it's not necessary that you have to keep this name. You can change it. But name is not important. The content here. This guy is import to SwiftUI. And this is a body, right? Struct my app, which is an app. And the body, which is some scene or some view, whatever, right? So if the file contains at main, this is an indicator. If it is there, then that is the entry point of your applications. So when you start your applications, it activates this program first, this Swift. Why? Because it says at main. So you should have only one at main. If you have multiple other at mains, then your app may be confused, right? So at main, that is the entry points. So when it comes to here, then there is a content view. This content, when it says content view, that content view is this program. So this is the entry points, entry file. And in here, it says, hey, we need to activate the content view file. Content view is this second file here, right? Which is this. This is content view. Because highlight this so that you can see the content view. When you come here, then finally, remember the previous, it says app, right? What it does is a struct. Struct is a structure. This is a reserved word. So the name of this specific structure is my app. So this my app should appear here, my app. What is my app? My app is nothing but app, :app. So actually in object orientation, app is a type, app is a superclass, and this is a subclass, my app. So I want to create my structure, my app, which is in the type of app, because the app is already provided. I don't need to create from scratch app. App is already available. So why not simply plug into that templates? Okay, that's what it does here. Okay, come back here. So this is content view. So name content view here, right? What is a content view? That is a structure. What is the type of that content view? There's nothing but a view. Because it says view, we can see the view, right? But actually there is some other things. Oh, well, that's okay. All right, here. And then body, this is a variable. Okay, so one of the property here called the body, it's a variable. Body should appear if it is a view. Okay, body. What is the type of a body? type of body is a view. But we said here some. Why we said some? In the next slide, I explain that. And inside here, we have kinds of view UIs. One of the view UI is VStack, virtual stack. I want to make it vertical, two components, image and text. As we said here, there is an image and there is a text. Image is system image. It's called the globe. So globe image comes up here. And then we can do more method. Remember that you guys took the Python already, right? So when you activate a method, then you have an object, dot, and method, right? Object dot method. This is exactly that one's. This is an object. When you do this image, then you can construct an object of images. Okay, so this is nothing but an object of image. So this is an object dot image scale. This is a method with that large. Image scale is large. And you can further activate. This is very good in Swift. In Python, you have one dot, right? But in Swift, you can make more dots here. Everything goes with that objects. Multiple dot. In that way, you can put more effect on that view. What kind of view? That image view. I want to add more effect. So first effect is image scale. Next effect here is foreground color. Foreground color, what is it? Color. It's an accent color. I think this is red, right? The second UI is text. All right. And there's a hello world. So hello world comes up here. So we have two UIs, two views actually. So further in this slide, what is a struct here? Struct is to define a structure. So in SwiftUI, we represent one screen or one piece of UI. So that is a struct. Struct is one UI like this. On this view, on this UI, what is the type of view? Type of that UI? That is a view. And then body. So that's content view. And body is a body here. Every SwiftUI view must have a body property. So body property describes what the UI looks like. So this should be here, body, variable body, colon, and it shows you what the UI looks like. So it tells you the type of view, right? This is an object, this variable, colon. So but type of body is a view. So it can give you a view, specific view. For example, in this case, image, and in the case, text. So it gives you a specific view. But at this level of declaration, it doesn't say any specific views. So this is very, very tricky, right, in Swift. Rather than specify, it says some view. So I wanted to use a some view. You don't need to worry about. You don't need to change it. Simply use a some view. This is not typed. This is a given. You will see what it is. Okay. So we'll do that. So why we say some? If we do not say some, then this kind of the UI, image, text, they look very readable, understandable, right? But in real coding, if we don't say some view, but if we enforce to make it more explicit and exact type, view type, then it should be like this. Modify the content and text and padding layout, comma, something like this. So this is, if you want to code like this, then this gives you a headache, right? So rather than having that, simply having this some view, it allows you to very readable code, text, image, and more. And a function. This is a the same in the same file. We struct content view and view, body colon some view. So far we looked at that, right? And then p stack, and we have image, text, and multiple text, right? And some of the declaration here, variable, and we declare the two variables and one constant. When you say constant, we need to say let. If it is a variable, var variable, we can say the type of that, like this, integer. Variable user age colon integer. So variable user, your age, this is a variable. This is a variable. What is the type of that variable? So it's a colon int. This tells you the type. And then we initialized. Initially, it is 25. Although it is 25 initially, it can be changed because it says variable. But if we say let, which is constant, then it cannot be changed. It should be always true. So is adult, that is a Boolean, right? Boolean values. And another variable, my age, int, and then a question mark and nil. Question mark, then that is implicit variables. Right now that is a nil, but it could be something else, right? Later. But anyway, at this point, we put nil. So somewhere here, we have a function, process age. So this text simply say hello world, like this. And then text string your age. Your age is a variable that we already defined here. That is 25. 25 is nothing but integer. There because that is an integer, then we have to convert it to a text. So function converting from integer to text is string. So we call string your age. Everything can be in text. So 25 here. And another text here, my age. My age is nil. So it is written nil. And then text is adult. Is adult is a Boolean, right? So we have question mark. If it is true, then you can say you are an adult. If it is not true, then next one after the colon, you are not an adult. So depending upon this, is adult. Right now, is adult is true. Therefore, it should say you are an adult. So we have you are an adult. And then next one is 425. If it's 25, 25 is goes to here, process age. This is the function call, function invocation, function that we defined here, process age. We enter 25. Then 25, if you see here the declarations, in Swift, we need to say two parameters. Okay, first one is actually arguments, right? First argument is underscore, second argument is an ag. Second argument is used for invocation. The first argument is used as a local variable. Okay. Underscore means, or actually, the other way. The first variable is the invocation variable. So when we invoke, if we say here x, then when we invoke, we have to say x 42 as an x. That's what we have to say. If we say underscore, then we don't need to say anything. Age is internal local variable. So that age is used here. Okay. So 42, this together, this is not two arguments. One argument, but specified in two components here. So first component is for the invocation. Second component is for local. So 42 comes here, then 42 as when it is called, we don't need to say because it says underscore. When it comes here, then 42 can be handled by the variable ag because it is local. So guard let valid age. Guard is something, I'll explain that later, okay? So today we simply do, if we say guard else, so we declare this, let this variable equals ag. So 42 is assigned to a new variable valid age. This is a new variable. So this valid age is returned here, right? That is returned. It says return. From here, that is a guard. Okay, guard, we declare that, and else, if we cannot declare this constant, then we can activate else components. Everything inside here, that is else. It returns 0, return nothing. If we successfully assigned, because that is valid age comes when this function is called, like this time, 42 comes here, so it can be assigned to valid age. Therefore, we simply print the valid age and return. Then 42 comes here. So text 42:42. That's what comes here, right? And next one is for XYQ, that is a string, and we also invoke process ag int xyz because we want to return. This is a type of these variables, right? :int, integer. Integer is optional. Anyway, xyz int, then it doesn't give any integer, right? So because it is not an integer, so we cannot assign this. because type of this should be an integer. Okay, type of this should be an integer. Because this is not an integer, we cannot assign. We cannot declare this. If this is invalid, then we need to do else part. When it comes to else part, invalid, that can be printed. This print is nothing about this view. This is not displayed on the UI. This is some like terminals, console, so you will be able to see how it works. Only it returns 0 in this case. So that for XYZ, and then it displays zeros. I think I'm going to stop this and we need to practice. Okay. So all right, how you need to do? You need to here Xcode. Xcode needs to be installed. Okay, by the way. So click that Xcode, and then we need to create new project. Click this. And as I said, iOS needs to be highlighted, and then click this app playground. Later we will work on this app development, but today we'll do app playground. Click on next, and then the name of that playground, so that we can say lab 1 playground 1 and test. And then team, this is my name, and I already made that, right? This picked up from this very easily, right? And then I can say next button. And where I want to save this, then I can say I want to make a new folder and class. I want to make inside the class and then create that. Okay. So this is general, because this is highlighted, general and signing and capabilities. You should have here signing is done. Make sure there is something. Xcode automatically manage provisioning profiles and signing certificates for the Swift Playground projects. And package and dependencies we don't need to do right now. Okay. This is a topmost the folder. By the way, when I ask you to submit your homework assignments, you need to submit this. Okay. Under this, if you click this, that is all inside. And this is that we can see unfold, fold and unfold. 2 programs given by default, right? So my app, if you click my app, then you can see here, as I explained, right, these 2 things. And then we activate the content view, which is this content view. So that you may be able to see that, right? So globe, large. And if you want to make, let's say, make it smaller. And by the way, if I want to click this, then I can see the console. This is a console. Okay. So if you click this, then it will disappear and appear like toggle buttons. Same thing here. Then that is hidden, and this can appear. So a lot of buttons, but we will look at that later. So here, for example, if I do no, we have to do inside here. I want to declare variable your age. And we can say here 25. That's okay. And then we can say let is adult. There is a Boolean. This is a very good ones here. Say is adult rather than saying we enter the specific number, right? I mean specific Boolean values are true. But we can do here Boolean values that comes from here. This is a predicate. So depending upon your age, here your age, if it is greater than 18, then we can say is adult. That is true. If I change your age a little bit later, then your age will become false, right? If we reduce that. So simply, I can say text and your age. It says, see what it says. It said that is int, right? Integer. So if we say, either we can say string, then it can be 25. Or we can do text, we can make that inside like a string, but inside the your age. If we say your age, simply your age, then that literally your age comes here. But I want to say, I want to make this a variable within this quote. If I want to do it, then I need to do escape character, backslash, from there to here. So that everything here inside that is a string, like I explicitly convert the integer variable to string, rather than having this the string function invoked. But I would simply say, let's put it in the string, but I want to make it escape. So it'll be 25 comes here, but 25 will be in double quotes. That works just like this. 25. Right? This is okay because we said the quote and double quotes. That's what this exactly is, right? And now I want to define a function. So if we want to define function, then we need to func, and then we can say process age, and then underscore and age, they are in integer, optional. I will explain that later, what that optional is. And then this function returns integer. Okay, but inside of that function, initially there is an error because there's no return, right? Because it said return. This is return type. This is the input parameters. This function returns integer. Locally, I would say let valid age that is assigned the value passed from the caller, we call that age, that is assigned to my local variable valid age. But in order to do, for example, exception handling, I want to do a guard. Guard is not really kind of exception handlings. If this declaration, this assignment is okay, that assignment valid, then we keep going, which means return. Other than that, we put here else. If it is not working, then we need to do some of the else part. In this case, we need to do return 0. In this case, return valid age. But if we say valid age is, well, let's put like this. And then we can do a text. And I want to call calling a function, and then we can say the function we have to put here escape characters, and then processing that for age here. I want to put, for example, your age. So your age comes here and assigned to valid age, because your age is valid. Your age is nothing but here 25. That is a valid integer. So that's a valid integer. So this assignment, this declaration is valid. Therefore, we don't need to worry about this else part. But going to next ones, it says return valid age. So 25 valid. By calling a function, we have 25 also. Okay. If you say here, because this is an error case, if you want to say something, then you can say print error. Takes place here. When that happens, there is, for example, text. By invoking a function, and then we can say that if I send the nil, then when it comes here, nil is not an integer, so we cannot assign that. So we go to else part. The first statement in the else part is print statements. Error takes place here. So this is a console. Print this print statement has nothing to do with this view components. If you want to say something on view, then you need to say text. This is a UI, graphical. This is a user interface. Print is not user interface. So if you say print, then print comes up here. If you say text, then that is the view that comes here, right? So by invoking a function, then it'll be 0, right? So the last test, I would say according to computation, here back escape character, and that. Within that, I would say process age, and then your age. Of course, then that is 25, but I want to what am I saying here? Let's say -5. Then everything here that can be computed, right? So here that's a function invocation. So it'll return 25 and -5. So it'll have here 20, right? So everything that can be, for example, I want to put that in no, I want to set here. I want to have variable her age equals processing age of your age. And I would do say here your age and -5. That's what I want to say here. Okay. And then rather than having that, I would do backslash that, and then her is adult. No. Is she adult? I would say. Is she adult is not defined, right? So we can say still that is she adults, same as that, right? Her age, 18. is she adult? Is she adult? Boolean. If it is over 18, then true other than false. But here, is she adult? What is her age? Her age. Oh, 20. Because it's a 25-20. I would just say here, maybe 9. Therefore, it'll be false, right? Because is she adult? I said here negative 9. This is the same rule, right? Same rule. So she is not an adult. False. This kind of things, so that we can call this function. Function can be called here in this declaration, and also the function can be called like this in this view. I think so. We have some of the error messages comes up here. All right. I think this is it for this time, the initial practice. Okay, so I want you to do this, your homework, first and second homework assignments, simply like this. I want to make sure that you are working on your. I want to see whether you are ready to move further. So you can simply do this on your MacBook, and then submit. In this case, you need to submit this. So how can you submit that? Let's see. That is, for example, in my case here, I have it here class, right? If you open up class, then this is the program. So you need to submit this. Okay, to not submit this individual like this file or that file. I want you to submit this as a whole. So what you need to do is, I think you need to do, you better do compress. Yeah, compress here. Compress. So this is compress, zip files. So that I can open this. Let's see. I want to close this. So when I receive this, so I can unzip it. Then I have this. So when I click this, so that I can see your work precisely, right? So what you need to do is you need to on here you need to make a the compress. So send it to that compress files, which is zip files, as your deliverables. Okay, I think this is it. Again, so this is the second module of this semester. From the third module, I'm going to meet you face to face in the Manhattan campus. Okay, see you there in person next week.